which is equivalent to, this can be written as n of A into n of B. What is n of A? 2. That means number of elements in set A, 2 elements. Number of elements in set B, which is also 2 elements. 2 into 2, which is equivalent to 4. So how many elements in Cartesian product of A cross B, which is equivalent to, general formula is n of A into n of B, which is equivalent to 4 in this example. Right? Then, how many subsets are possible? How many subsets? Total number of subsets is equivalent to total number of subsets of which one? A cross B. A cross B equivalent to 2 power n of A into n of B. 2 power n of A into n of B. In this example is what? 2 power 4. Okay, guys?
Yes, sir.
Total number of subsets of A cross B. A cross B means for generally Cartesian product. You know? So that is equal to 2 power n of A into n of B, which is equal to 2 power 4 in this example, which is equal to 16 subsets are possible. Right, Amma? Next, what is the relation? Now we are going to apply the definition for relation. A relation. What is a relation between? Definitely the 2 elements. This relation is generally defined as what? A comma B. That means what? A related to B. General meaning is what? A related to B means what? Its definition goes to, that is a subset of A cross B. A subset of A cross B, where A and B are, two non-empty sets. 2 non-empty sets. 2 non-empty sets. So, how many subsets are possible? 2 power n of A into n of B. These subsets, any one you can take. That is called a relation. Relation is what? Relation is a subset of which one? Cartesian product of 2 sets. That is relation. Clear, guys?
Yes, sir.
Pratipan Chetana.
Yes, sir.
A subset of which one? Cartesian product of A and B. Any relation, any subset. So, how many relations are possible? Total number of relations. Total number of relations on A to B. A to B means what? The number of subsets, which is equivalent to 2 power n of A into n of B. So, how many relations are possible between the 2 sets A and B is 2 power n of A into n of B. Simultaneously, you are copying these points. Students, simultaneously you are copying.
Yes, sir.
Yeah. Next. Types of relations. How many types of relations are possible?
Two, sir.
What are they?
empty relation and universal relation.
Empty relation and universal relation. No. Chetna, in your school they completed this part.
Reflexive, transitive, and symmetric.
Yeah, reflexive, symmetric, and transitive. Yeah. Good, Chetna. Types of relations. Types of relations. First one is what? Reflexive. What is a reflexive relation means what? What is reflexive means in the relation A belongs to A means then A comma A is belongs to R. Like here R means what? Relation. Remember? A belongs to capital A means A comma A is also in the relation. Then relation R is called what? Reflexive. Clear, guys? Reflexive or identity is also we can refer. Number 2, symmetric. What is symmetric relation? A comma B belongs to R, then B comma A is also belongs to R. Here, capital R means relation not by the real number. Okay? A comma B belongs to R means B comma A is also belongs to capital R. Number 3, symmetric transitive. Transitive. So, what is a transitive means what? A comma B belongs to R and B comma C belongs to capital R relation. Then A comma C is also belongs to R, then which is called transitive. Clear, guys?
Yes, sir. Yes, sir.
So, reflexive, symmetric, and transitive. Now, any relation satisfies these three. Any relation satisfies these three relation means what? That relation is called equivalence relation. Equivalence relation. Any relation which satisfies these three, then the relation is called equivalence relation. So here, can we do the problems?
Yes, sir. Go ahead, sir.
Yeah. Write down the question. Write down the question. The relation capital R. The relation capital R in the set A equivalent to 1, 2 and so on up to 40 defined as capital R equivalent to x comma y, which is an ordered pair, where condition is what? Where 3x minus y equivalent to 0. 3x minus y equivalent to 0. Well, what is the condition means what? Identify whether capital R is reflexive, symmetric and transitive. Identify capital R is a reflexive relation, symmetric relation, or the transitive relation. First, apply the value. What is the relation R? Relation R is what? Which is on x comma y. Which relation are they saying? A. Such that y equivalent to 3x. Or 3x equal to what? 3x equivalent to y. So that is equal to capital R equal to x starts from which one? 1. When x equal to 1, what is y equivalent to? 3 amma?
3, sir.
Similarly, when x equal to 2,
6.
y equal to 6. Next 3 to 9.
9.
Right, amma? And so on. After what is the maximum? When
4,
x equal
12.
to 40, what is y equivalent to? 14 3s are
42.
42. Right, amma? So 40. Now, this is the elements in the relation R. Now, go with one by one. Is it reflexive? Is it reflexive means what? What is generally reflexive? A comma A is also in the relation. But what is the element here? 1. 1 comma 1 is there?
No, sir. It's not reflexive.
No. That means what? If one thing is not there, means what? R is not reflexive. Right? Okay, amma? Clear, Gadi?
Yes, sir.
Chetana?
Yes, sir. Yes, sir.
So 1 comma 1 is not there because what are the elements we are having? 1 to 40. 1 comma 1 must be there, 2 comma 2 must be there. But in this relation, 1 comma 1 is not there means what? R is not a reflexive. Next, symmetric means what? What is the definition from symmetric relation? A comma B belongs to R, B comma A is also belongs to relation of R.
Yes, sir.
Take care. 1 comma 3 is there, but 3 comma 1 is not there.
Yes, sir.
So that means what? R is
Symmetric.
not symmetric. Not a symmetric. R is not a symmetric. Next, what about the transitive? 1 comma 3, then is what? 3 comma 9. Then 1 comma 9 is also is there or not?
No, sir.
That means what? So R is
Not transitive.
not a transitive. But it is a relation, right? Clear, Kadeep? And Chetana?
Yes, sir.
Yes, sir. Sir, one doubt, sir.
Yes.
Sir, but 42 does not belong to set A, so how can it belong to the relation?
Right. I mean, relations completely on A comma A. So the maximum to which one?
4, comma 12,
4,
sir.
2.
4 comma 12. Okay. So 1 comma 3, 3 comma 9, but 1 comma 3 is not. I mean, maximum we need to take the elements from 1 to 40 level. Understand completely?
Yes, sir. Yes, sir.
Hmm. Next question, can we move?
Yes, sir.
Next question, madam. Copy it completely.
Yes, sir.
Next question. Relation R in the set capital N. A relation capital R in the set capital N. Set capital N. That means capital N of natural numbers. N of natural numbers. This is defined as x comma y equal to x plus y. Such that y equal to x plus 5 and x is less than 4. X is less than 4. Relation R in the set capital N of natural numbers defined as f of x comma y is a ordered pair, y equal to x plus 5 and x is less than 4. X is less than 4 means what are all the numbers we can take? 1, 2, 3 only.
6, 7.
So y equal to x plus 5 and x is less than 4. So x is less than 4 means start with. I think this one is also. When x equal to 1, y equal to 6.
1 comma 6, sir.
2 comma
7.
7. 3 comma 8. That's all. So natural numbers only we need to take, and also x is what less than 4 only. Similarly, here is also 1 comma 1 is not repeated. 1 comma 1 is not there in this relation. That means what? Which is not a reflexive, right? So which is not a reflexive, not a symmetric, and also not a transitive. Clear, guys?
Yes, sir.
Okay, Chetana and Katik.
Yes, sir.
What is the next question is? Third question. Third question is set A equivalent to 1, 2, 3, 4, 5, 6. X comma y. What is the relation is? Y is divisible by x. Y is divisible by x. That is a relation. Y is divisible by x. Then first find out what are the elements in the relation. Y divisible by x means what? X divides y. But the values are only we need to take 1 to 6 only. So what is the relation is y is divisible by x. Then what are all the elements here? First, 1 comma 2 is possible.
Yes, sir.
2 is divisible by 1.
Yes, sir.
Sorry. 1 comma 1 is also possible.
Yes, sir.
So 1 is divisible by 1. Next is what? 1 comma 2 is also possible. 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Clear?
Yes, sir.
Next. Start with 2. 2 comma 2. Clear, Amma? And then 2 comma 4. 2 comma 6. Is it clear?
Yes, sir.
Next. 3 comma 3. And then 3 comma 6. Clear, Amma?
Yes, sir.
Any other element? 4 comma 4 is possible.
Yes, sir.
4 comma 5 is not possible. 4 comma 6 is not possible. Next one is
5, 6,
5 comma 5 and 6 comma 6. Okay. Now, in this relation, what are the elements? 1, 2, 3, 4, 5, 6 are we need to use. So, 1 comma 1 is there. 2 comma 2 is there, 3 comma 3 is there, 4 comma 4, 5 comma 5, 6 comma 6 is there, means what? Therefore, R is a reflexive. Okay guys, R is a reflexive.
Yes, sir.
R is reflexive. Now, find out R is a symmetric or not.
Not symmetric.
What about the base? One comma two, 2 comma 2, 1 comma 2 is also there. One comma 2, 2 comma 4, 1 comma 4 is also there. 1 comma 2, 2 comma 4. That's it. Symmetric they are not taking the transitive. So this is not a symmetry because 1 comma 2 is there, 2 comma 1 is not there.
Yes, sir.
So R is not symmetric. R is not symmetric. Is it transitive? 1 comma 2, 2 comma 4, 1 comma 4 is there. Next, 1 comma 2, 2 comma 6, 1 comma 6 is there. Any other chances? 1 comma 3, 3 comma 6, 1 comma 6 is there. 1 comma 4, 4 comma 4, 1 comma 4 is there. 1 comma 5, 5 comma 5, 1 comma 5 is there. 1 comma 6 comma 6, 1 comma 6 is also there. Therefore, R is what? Transitive. Clear guys?
Clear.
So on what basis we are taking R is a transitive means what? 1 comma 2 is there, and then 2 comma 4 is also is there, then 1 comma 4 is also in the relation. Clear? Katiban Chetna?
Yes, sir.
Yes, sir.
Yeah. This is an example. Similarly, one more one is also we can take. Happy guys? Completed? Set Z is defined by set the relation Kepler in the set Z is defined by x comma y. X minus y is an integer. X minus y is an integer. So, what is the relation? X minus y is an integer. So, what are the elements we need to use? Integers. That means minus infinity to infinity. First, reflection. What I am going to write? X comma x. X comma x means what? X is related to y. X related to y means what? X minus x, which is equal to 0. 0 is an integer. Clear guys? Take the two integers, not the two integers, the same integer. So, x comma x. X related to x. X related to x means what? What is the relation? X minus y is an integer. That means x minus x, which is equal to 0. 0 is an integer. That means what? It satisfies the reflection. Therefore, Kepler is a reflection. Kepler is a reflection. Second one is what? Two, symmetric. Symmetric means what? X comma y, which is equal to what? That implies x related to y. What is x related to y means what? Which is implies, x minus y is an integer. X minus y is an integer. Then what about y comma x? Y comma x implies we part y related to x. Y related to x means then y minus x is also an integer. If x minus y is an integer means what? Y minus x is also an integer. Clear or not?
Clear.
For example, 1 comma 5. I am taking 1 comma 5. So here we need to take whether it is there or not. Don't take which two values are equal. So what is 1 minus 5? 1 minus 5 equal to minus 4. Then what about 5 comma 1 now? Which is equal to 4. Both are integers only. Don't take whether it is a positive, same or different. It is there or not only. So 1 comma 5 is there means what? 5 comma 1 is also is there. So that implies the R is what? R is symmetry comma. Okay, Chaitana and Gadi.
Yes, sir.
So R is a reflexive and R is a symmetric. Next, moving into transitive. Definitely, right? Definitely, it is a transitive. So for the last one is what? For a transitive. For the transitive. What means what? x related to y and y related to z. X related to y related to z. That means what? X minus y is an integer, y minus z is also an integer. So what we are going to do here, then what is x? That means what? X comma y is an integer. Similarly, y comma z is also an integer. And so now what I am going to do here, x comma z. X comma z, we need to prove it as an integer. So x comma z equivalent to what? X minus z. X minus z is an integer we need to prove. So what we are going to do here, x minus y plus y minus z. Clear, Amma? Addition of y and subtraction of y. You can able to view the last point.
Sir, no, sir.
So there is a
But there is.
So what we did here means addition of y and subtraction of y. Now what is x minus y? X minus y is an integer. Plus y minus z is also an integer. So integer plus integer, which is equivalent to integer. So x comma z is also an integer, means what? So Kepler is a transitive.
Sir, board kira terla sir. Okay.
So finally, here this relation satisfies reflexive, symmetric and transitive. Then the relation Kepler is called what? Equivalence relation, Amma. Completed, Katik.
Yes, sir.
Completed, Chetana?
Yes, sir.
Yeah. Next one. So next relation is What is the given question is, relation is what means? What is FR equivalent to A comma B such that A is less than or equivalent to B square. A is less than or equal to B square. And R is the set of real numbers. R is the set of real numbers. Identify. First, take A is any value. For which one? Reflexive property. It satisfies the reflexive property. A, that means what? 1 comma 1. That implies 1 is less than or equal to 1. Is it true, Amma? Now, it is a reflexive. 1 is less than or equal to 1. Next, what they said here? R is a set of real numbers. Take another one. 2 comma 2. 2 comma 2 is what? 2 is less than or equivalent to 4. Correct, Dharma? 2 is less than or equivalent to 4. It is reflexive. Sorry. 2 comma 2. A minus B square. That is less than 0. Then another element is square. 3 comma 3. 3 comma 3. 3 is less than or equivalent to its square. That is 9. All then minus 1 comma minus 1. Because all real numbers. So minus 1 comma minus 1 means what? So minus 1 is less than or equivalent to minus 1 square plus 1. So it satisfies reflexive, Amma.
Sir, what about 1 by 2, sir? Fraction.
Yeah, that is. So R is the set of real numbers. If we take 1 by 2 comma 1 by 2, because all reals, but here we consider only for integers. So in this case, 1 by 2 is less than or equivalent to 1 by 4. 1 by 2 is never less than or equal to 1 by 4. That means 0.5 is not less than or equivalent to 0.25. So it satisfies for all the elements. So that means what? It satisfies only for integers, not for the rational numbers. Clear, guys?
Clear.
This relation satisfies on the reflexive only for integers, not for the fraction parts. So that means what? R is not reflexive. R is not a reflexive. Here does not satisfy. Next of all, symmetric. Symmetric means what? Take 1 comma 2. 1 comma 2 means what? That is 1 is less than or equivalent to 4. Then 2 comma 1 means what? 2 is less than or equal to 1, which is not satisfied. So 1 comma 2 will be there. That means since 1 is less than or equal to 4. 2 comma 1, which is not satisfies the relation. 2 is not less than or equal to 1. Therefore, R is not symmetric. R is not symmetric. Now the last one, transitive. Check 1 comma 2 and then 2 comma 3. which will satisfy 1 comma 2, 1 is less than or equal to 4, 2 is less than or equal to 9, then 1 is less than or equal to 9. It satisfies.
Kirna, log in at maths faculty is taking class. 3-4 minutes to go. Just see how he's taking.
Transitive. For integers, it satisfies. For integers, it satisfies. Then what about the fraction part numbers? Fraction part numbers means real numbers will satisfy. Okay. So this is 1 by 2 is less than 1 by 9. One by 4, comma 1 by with A comma B general by applying the general. By applying the general means what? A comma B, which is equal to A minus B square, which is less than 0. B comma C, which is equal to B minus C square, which is less than or equal to 0. Then what about A comma C, which is equal to A minus C square, which is also less than 0. A minus C square. A minus C square is there, but here B square and B will be there. One cases is a B square, another cases is a B. So which is equal to A minus C square plus B minus B plus B square minus B square plus B square minus B square. Now what I am going to do here with A minus B square, and what is another one? B minus C square. A minus C square and B minus C square. So we written as A minus B square plus B minus C square. So balance is what we are having here, plus B square minus B. A minus B square is a real, it's a negative, but the given, so which is negative, which is also negative, but we don't know what is the B square minus B. B square minus B, which may be the value. But that is also we cannot conclude that one. 1 by 4 comma 1 by 3. What I am going to 1 by 4 comma 1 by 3. 1 by 3 comma 1 by 3. These are the sets. 1 by 3 means what you have. So 1 by 4 is less than 1 by 9. There you go. Fraction part was at say how 1 by 4 is less than or equal to 1 by 9. Then what is your 1 by 3 is less than or equal to 1 by 4.
Sir, R is not transitive, sir.
Huh?
R is not transitive.
Transitive for what values? R is either transitive or not a transitive. For what values it is not a transitive. That one I am finding.
Real numbers. Sir, take any random number, sir.
No, for integers it is satisfied, sir. Integers it is satisfied. Take any number. So 2, 3, 3, 5. Right? 2, 3 and 2, 5. So between 2, 3 means what? 2 is less than 9. A is less than or equal to B square. Similarly, 3 is less than or equal to 25. Then obviously, 2 is less than or equal to 25. For integers, it is satisfied, sir.
Yes, sir.
Integers, it satisfies me. But what about the fraction part?
It doesn't satisfy, sir.
Definitely. What are the numbers? I mean, orally I can say it satisfies for integers means it won't satisfy for the fraction part, especially between the numbers 0 and 1. Clear, Amma?
Yes, sir.
For example, A is less than B means what? 1 by A is not less than 1 by B. A and B, A is less than B means then 1 by A does not less than 1 by B. But here what is what here? 1 by A is greater than 1 by B. Its reciprocals definitely will change the inequality. Clear, guys? If A is less than B means what? 1 by A does not less than 1 by B. 1 by A is greater than B only. I mean, orally I can say what are the numbers, alright. So for what are all the numbers? Take fraction part numbers between 0 and 1. Any fraction part numbers between 0 and 1. But here the B square. So 1 by 5. 1 by 5, 1 by 4. Then 1 by 4, 1 by 6. As simple as 1 by 2, 1 by 3. 1 by 3, 1 by 4. 1 by 2 is less than 1 by 3. Is it true or not? This relation is satisfied. Definitely we can say. So that means what? 1 by 2 is less than 1 by 9. That means what is the reciprocal? 2 is greater than 9. This does not satisfy. So that means what? Here 1 by 3, 1 by 2. 1 by 2, 1 by 4. So 1 by 3 is less than 1 by 4. This will satisfy. So wordings we can say which is not a transitive, but how we can prove? So relations based export is the setup of the numbers. 1 by 3 is less than 1 by 4. 1 by 3 means fine. This is right up. Fine 3 is less than 0.25. Satisfy our other. So, which is not transitive. R is not transitive. R general was general in generally A comma B. What out A comma B equivalent to A minus B square, which is less than or equivalent to C. B comma C which is equal to what? B minus C square, which is less than or equal to 0. Then what about A comma C, which is equivalent to A minus C square plus B minus B plus B square minus B square. So that is equivalent to A minus B square plus B minus C square, A minus B square, B minus C square plus B square minus B. So that means what? We cannot say which is what? Neither positive nor negative. Neither positive, sorry, either positive or negative. Some cases which will give positive, some cases which will give the negative. That means what? So capital R is not a transitive.
Sir, if you take integers also, it won't satisfy, sir.
Integers satisfy ஆகுதுல்லமா?
ஆகாது சார் இன்டிஜர்ஸ்ல.
What are the integers?
சார் 2, -3 எடுங்க சார்.
2,
-3 -3, 1 எடுங்க சார். சாட்டிஸ்ஃபை
2,
ஆகும்.
-3
-1
அப்போ 2 is less than or equivalent to
-3
square.
9 sir. Sir,
It satisfies.
it satisfies.
Right? Then coming to here, 3 -3 is less than or equal to what is satisfy ஆவதில்லை in the relation. Right?
Sir, 2 greater than 1 வரும் sir. 2
Is satisfy -3 is less than or equivalent to 1.
இது satisfy ஆகுது sir.
It satisfies. அப்போ இது கேட்டுங்க. Then coming to these two.
2 1
2, 1. 2, 1 means what? 2 is not less than or equivalent to 1.
satisfy ஆகாது sir.
Satisfy.
So it is not transitive.
Not transitive. Okay. In that way, our general means what? So, what is A comma B relation? B comma C relation. Now I'm taking A comma C means what? We want to prove that which is a completely negative. So, by adding B and minus B and adding a subtraction of B square, then which is not always negative. Some cases which will be a positive is also possible. That means what? R is not a transitive. This is an example. Chetana.
Sir.
இருக்கணும் sir.
6-1. 6-1. What is the set? The set is 1, 2, 3, 4, 5, 6. Why 6? What is the relation? Capital R equivalent to A comma B such that B equivalent to A plus 1. B equivalent to A plus 1. Seven. One more question. What is set is what? Real numbers. Set is real numbers. What is the relation? A comma B such that A is less than or equivalent to B. Verify reflexive, symmetric and transitive relations.